We are in the continuation of same lesson, pressure. So in the beginning, let's discuss the question associated with Archimedes principle. This is the diagrammatic question, dear students. You can see the diagram and the questions over there. One number question is there. On which principle is the experiment shown in diagram based? That means you have to name the principle. And next is state the principle. So you find two questions in question number 1. For this, first of all, let's observe the diagram carefully. There you can see spring balance. Okay, this device used to measure the weight of a body is called spring balance. A body is attached that we fitted with the spring balance, so which is going to be immersed inside the liquid. Then secondly, here in the diagram you can see a vessel with the spout. This is called spout, okay, from where the liquid displaced spills and get collected in another vessel called beaker. This vessel is called eureka can. Eureka can with the spout and beaker is placed on the top of balance. So whenever we see the diagram like this, friends, so spring balance, a eureka can, then immersed body, beaker, and top and balance. Okay, the diagram clearly shows. So this experiment is best. Yeah, you can say the answer, please. So if you have idea, so which principle this experiment is related to, you can say the answer, please. Yeah, yes, you're right. This is Archimedes principle. Yes, first question answer is for 0.5 marks. No, that is experiment shown in diagram is based on Archimedes principle. And the tell question is state the principle. Okay, among you who wants to say the principle given by Archimedes regarding upthrust and the weight of displaced liquid. So who would like to state Archimedes principle? So voluntarily you can, and you can say the statement of Archimedes principle. Archimedes principle states that when a body is fully or partially immersed in a liquid, then it means that body experiences an upthrust. And upthrust is given by the liquid, that is upward force. That body experiences an upthrust which is equal to the weight of displaced liquid. Okay. If a body experiences 5 Newton upthrust, means that the body displaces 5 Newton of liquid. That upthrust is equal to weight of displaced liquid. Got it? Now let's go to question number 2 from the same diagram. What is the weight of object in here? So we have been reading that weight of any object in here is always the real weight. That is the maximum weight of an object, right? For the earth. Here you can see in the diagram, okay, I think it's not clear, but also the weight that spring balance is showing when a body is immersed inside the water, a liquid is 20 Newton, 20 Newton. That is apparent weight, and that is the weight of a body. Weight it is inside the water. And if you see there the top end balance, okay, just by the side of top balance, that is written 5 Newton. That is not clear. This is 5 Newton. Okay, 5 capital N and for Newton. And when we find the weight given by the side of top end balance, or let's say beaker where the displaced liquid is collected, always remember that is the weight of displaced liquid. Right? Another weight of displaced liquid plus beaker, and that is just the weight of displaced liquid. So in the diagram, so we found weight of body inside water and weight of displaced liquid, right? And we have the idea that the weight of body in here is real weight, and the real weight can be mathematically calculated by the equation. Real weight is equal to apparent weight plus weight loss by the body, right? And according to Archimedes principle, weight of displaced water is equal to upthrust, and upthrust is equal to weight loss by the body. Means apparent weight is 20 Newton, weight of body inside water is 20 Newton. Then by the relation, that weight loss by the body is 5 Newton. So 20 plus 5, okay, in total are 25 Newton. Yes, you are right. Thank you. Yes, 25 Newton. Yes, weight in year is the real weight. Yeah, that is the maximum weight for a body. It is 25 Newton. So let's go to question number 3. So how much upthrust is exerted by water? Earlier, yes, you're right. Yes, that is 5 Newton. Good. So according to the principle given by Archimedes, that upthrust is equal to a weight of displaced liquid. And from the diagram, so we came to know the weight of displaced liquid or water is given 5 Newton, which is equal to upthrust. So upthrust is equal to weight of displaced water, and in place of displaced water, weight of displaced water, you can write 5 Newton. Means upthrust is also a 5 Newton. Got it? So did you understand the question? Now let's go to another question, please. So if you are ready, then we can jump to second question. Here, the questions is in tabular form students. Let me read the question, or you can see on your screen the different weights of an object. I stop here, I pause here. Okay, in the table you find the value, okay, of weight, just like 35 Newton, 50 Newton, 25 Newton. Just understand and get the concept. These are the weights of same object, okay, not of different objects. So weight for a particular body is variable. Okay, weight changes from place to place, and the weight of a body also changes from that medium, the weight it is measured. So we have the weight of the same object that is found in 3 different media. The media are pure water, salt solution, and air. Means among X, Y, and Z, okay, one is air, another is a salt solution, and the third one is pure water. You have to study the table carefully, right? Means data and give answers. So according to the questions, let's see the question number 1 first. So among this media, okay, out of X, Y, and Z, now which would be air and salt solution? Okay, simply you can say the name, just like X is salt solutions or air or pure water. Find the corresponding weight of object, okay, in different media. In X medium, the weight of object is 35 Newton. In Y medium, the weight of the same object is 15 Newton. In Z medium, and the weight of that same object is 25 Newton. The object is measured to find its weight in different media, okay, at different time. And when instance, among these magnetic value of weight 35, 15, 25, the highest value is 35 Newton. Am I right? Isn't it? The greatest value of weight of the object, so according to the question, is 35 Newton. Means the medium X is air. Okay. Yes, that air is X. Good. Yes. And Y is a salt solution. Yeah, you are absolutely right. Yeah, absolutely correct. So X is air, right? Because in air we get always the maximum weight of a body, because the air exerts less of thrust compared to other media. And between water and salt solution has more density. So due to which salt solution can exert or give more of thrust to it. So when the upthrust of a liquid or medium is more to a body, definitely the body is pushed up, means the weight decreases more. Means Y medium is salt solution. And finally Z is pure water. So X is air, Y is a salt solution, and Z is pure water. Let's go to question number 2. What is the weight of water displaced by a body in pure water? So standard medium, let's take air as the standard medium, where we have found the real weight of a body, that is 35 Newton, and medium X is here medium. And apart from it, we have two media X and Y and Z. So where Y is salt solution and Z is pure water. Now simply, okay, that compare X and Z. So to get the answer of question number 2, students, compare that to X and Z. The real weight is 35 Newton. So when we immersed, so as to find the weight of a body or object in pure water, the weight is shown by the spring balance equals to 25 Newton. So 35 Newton is real weight, right? Yes, you are again, okay, correct. Yes, thank you so much. So it is 10 Newton. Yes, the Z, the 25 Newton is apparent weight, 35 is real weight minus apparent weight is upthrust, which is equal to the weight of water displaced. Yes, because the medium is here pure water. So for pure water, so we are taking the weight in pure water. Z is pure water. So 35 minus 25 is 10 Newton. So 10 Newton of weight of what is displaced by a body. And let's go to question number 3. What is the upthrust exerted by salt solution? So for responding question number 3, now just look at two values, means look at the two media. Yeah, you are again right. So absolutely correct. Excellent. Keep it up, please. That is 35 Newton, the real weight, and the weight in salt solution 15 Newton. So weight lost by a body is equal to upthrust given by the medium, or you can say liquid, yes, or sometimes you can say fluid also. So 35 minus 15. So you will get 20 Newton, and that is the weight lost by a body when immersed in salt solution, means that is the upthrust exerted by salt solution. Good. Yes, 20 Newton. So did all the students get the answers of all questions? Are you clear, students? Okay, today I have brought these two questions, so related to Archimedes principle. Azur, please.
2 number, I didn't get it.
Number 2?
Yes, sir.
Okay, yes, question number 2, please let me again say the way how to give answer. The question is asking you to find weight of water displaced, right? So weight of water displaced is equal to upthrust, and which is again equal to weight lost by a body. And in this table, that real weight, that means in here is X means 35 Newton, right? And that the pure water is 25 Newton. The weight in pure water is 25 Newton. That means Z is pure water and X is here. So 35 Newton is real weight, and 25 Newton is the weight of that body in the water. That is apparent weight, right? And real weight minus apparent weight means 35 minus 25 equals 10 Newton is the weight lost by a body. And weight lost by a body is equal to upthrust. And according to Archimedes principle, upthrust is equal to weight of water displaced or weight of liquid displaced. Means question number 2 answer is 10 Newton. So did you get that point? Okay, to find weight of water displaced, just compare the weight in air, which is real weight, and the weight in water. Okay, and to find that the weight of salt solution displaced, just compare the real weight in air and the weight in salt solution. But in question number 2, so you are asked to find weight of water displaced. So why we have done comparative study in air and pure water, and here X is air and Z is pure water. So 35 minus 25 equal 10 Newton is weight lost by a body in water, right? That is equal to upthrust and again equal to weight of water displaced. So final answer is 10 Newton. I'm hearing.
10 Newton
which question number 3?
Yes, sir.
Question number 3 मा answer 10 Newton हुँदैन बाबु. Okay, सुन फेरि question number 3 मा चाहिँ salt solution भनेको छ नि त. 2 मा चाहिँ pure water भनेको भएर हामीले X र Z लियौं है. अनि 3 नम्बरमा त salt solution भन्ने क्लियरली छ र त. अनि salt solution भएपछि अब के कम्पेयर गर्न पर्यो भने X र Y, किनभने X here हो, Y के हो त salt solution हो नि त. अब तिमीले के बुझ्नु पर्यो भने जस्तै यो वेटको आधारमा छ नि सबैभन्दा बडी डेन्सिटी भएको सोलुसन अथवा लिक्विड कुन हो ओके जसको अपथ्रस्ट बढी हुन्छ भने त्यो जस्तै एयर वाटर र साल्सोलमा सबैभन्दा बढी डेन्सिटी भएको यो त साल सोलुसन हो अनि जुन लिक्विडको जुन सोलुसनको डेन्सिटी म्याक्सिमम हुन्छ नि त्यसमा बडीको वेट के हुन्छ बडी लस हुन्छ है तर यो 25 र 15 मा साल सोलुसन के हो त 50 न्युटन भयो क्या यो वाइ चाहिँ भयो किन यसमा चाहिँ बडीको वेट एकदमै धेरै लस छ नि त रियल वेट 35 छ राइट अनि घटेको छ वाटरमा पनि घटेको छ साल सोलुसन पनि घटेको छ तर सबैभन्दा धेरै घटेको कहाँ छ भनेपछि वाइमा छ अनि वाइ साल सोलुसन भयो अब तिमीले 3 नम्बरको एन्सरको लागि चाहिँ तिमीले एक्स र वाइ हेर्न पर्यो है एक्स भनेको 35 न्युटन छ रियल वेट वाइ भनेको साल सोलुसनमा अनि इमर्स गर्दाखेरि बडीको वेट कति भयो 15 न्युटन भयो भनेपछि अब यो रियल वेट 35 अनि 15 के हो त एपरेन्ट भएपछि 35 माइनस 15 गर अनि एन्सर कति आउँछ 20 न्युटन आउँछ है अनि त्यो 20 न्युटन भनेको चाहिँ यहाँबाट वेट लस हो तर वेट लस केसँग बराबर हुन्छ बाबु अपथ्रस्टसँग बराबर हुन्छ नि त तर अपथ्रस्ट पनि कति भयो त 20 न्युटन भयो है तर क्वेसन नम्बर 3 को एन्सर अपथ्रस्ट एक्जर्टेड बाइ साल सोलुसन इज 20 न्युटन अलि क्लियर छ बुझ्यो
Yes, sir.
okay now let's read the today's topic this is law of flotation so last time also we talked a little about law of flotations its statement थोरै हामीले कुरा गरेको थियौं okay for this students I have a question at what condition does a body float on liquid सुन्दैछौ है कुन कन्डिसनमा बडी कुनै पनि बडी लिक्विडमा अथवा फ्लुइडमा फ्लोट हुन्छ so what is the conditions in which a body is found floating on the liquid we used to say that when a density of a body yes you are right yes when a density of a body is less than the density of liquid and such body always floats on the liquid I repeat जब कुनै बडीको डेन्सिटी लिक्विडको भन्दा कम छ भने त्यस्तो बडी लिक्विडमा फ्लोट हुन्छ भने हामीले पहिला पढ्ने गर्थ्यौं अथवा त्यस्तो कुरा हामीले हैन डिस्क्राइब अथवा चाहिँ डिस्कस गर्थ्यौं राइट नाउ वी कनेक्ट टु अनदर टर्म दैट इज द कन्सिक्वेन्स अफ डेन्सिटी अफ लिक्विड त्यो टर्म भनेको के हो त क्लास भने अपथ्रस्ट हो राइट सो व्हेन अ बडी okay that experiences upthrust equal to its weight means when a body is able to displace the liquid equal to its weight so in that condition a body floats on the liquid फेरि सुन कुनै पनि बडीलाई लिक्विडमा इमर्स गराउँदाखेरि त्यो बडीको वेट जति छ नि त्यति नै वेट बराबर उले लिक्विड डिस्प्लेस गराइदियो फर एक्जाम्पल बडीको रियल वेट 50 न्युटन छ है बडीको वेट हामीले इयरमा मेजर गर्दा 50 न्युटन 50 न्युटन छ भने त्यो बडीलाई हामीले अब वाटरमा राख्यौं राख्दाखेरि 50 न्युटन वाटर नै त्यसले डिस्प्लेस गर्छ भनेको मतलब त्यसको एपरेन्ट वेट कति हुन्छ 0 हुन्छ है रियल वेट बाहिर इयरमा मेजर गर्दाखेरि 50 न्युटन छ अनि भित्र वाटरमा राख्दाखेरि ओके त्यसमा चाहिँ 0 त्यो बडीको वेट देखाइदियो भनेको मतलब के हो नि उले आफ्नो वेट बराबर उले के गर्यो वाटर डिस्प्लेस गर्यो अपथ्रस्ट त्यति नै पायो के 50 न्युटन वेट रियल थियो 50 न्युटन नै अपथ्रस्टले पायो भने सो इन दैट केस a body always floats on the liquid so which is the principle so called principle of flotation or law of flotation so for a floating body or the standard principle law is weight of the floating body is always equal to weight of liquid displaced naturally originally okay if a body's density is less than the density of liquid that means so it always have the weight equal to the weight of displaced liquid okay or sometimes even it can displace the liquid okay more than its weight so in that conditions okay it always floats so that the floating occurs in two ways so we'll discuss in another slide so one is on the surface and another is below the surface just know here the relation between the weight of a body okay which floats and the weight of the liquid displaced so we are not talking about the weight of a total liquid okay either in the vessels or in the sea or river like that so how much liquid does a body displace only that displaced liquid weight we are talking about. And if the weight of that displaced liquid is equal to weight of a body, and the body always, okay, that floats on the liquid. This is a part of Archimedes principle. So it also talk about that upthrust and the weight of displaced liquid. So according to Archimedes principle, so no matter whether a body sinks or floats, always that the upthrust is equal to that is weight of displaced liquid. But in such conditions, when that upthrust is equal to weight of body, that means weight of displaced liquid equal to weight of body. In that case, now body does not sink. Body comes to the surface or lies below the surface. Please remember this law given by the law of flotations. Now let's verify law of flotation experimentally. For this strength, we need again a measuring device called spring balance. And for this activity, always remember to take a body which floats. Here, if you take an object like iron, or let's say other which has more density than the liquid or water, at that time we cannot verify the law of flotation. Means we are trying to show that the weight of floating body is equal to weight of displaced liquid. So for verifying this principle, we must take a body which originally or naturally floats on the liquid, and this time we are taking water as a liquid. For this also we are taking Eureka can. This vessel is called Eureka can, and this is beaker. Okay, we take a empty beaker, so which is placed on top and balance, right? It shows the weight of empty beaker first, and when the liquid is filled in it, it shows a total weight of empty beaker, and let's say that is weight of that is displaced liquid. And finally we can get the weight of displaced liquid only or water only. Okay, first just measure the weight of a body in here, so which is real weight. For example, we found the weight of that a piece of wood or a piece of oak, whatever you say, so which has less density than the water, 14 Newton. This is the real weight that we have measured the weight of that body, in here. The real weight is 14 Newton. And after just separating that body from the spring balance, now we place the body inside the water, so which is kept in Eureka can. And during this process, students, always remember, take care of one thing. So before placing the body inside the water, we have to fill water up to the level of spout. Okay, so that when a body displaces water, the displaced water all gets spilled and get collected in the beaker. सुन है, हामीले यो वुडको पिसलाई यो युरेका क्यानमा राख्नुभन्दा पहिला नै पानी जब हामीले भर्छौँ नि, भर्दाखेरि यो स्पाउटको लेभलसम्म, टप लेभलसम्मै भर्नुपर्छ है, तल र भरि भरेन हैन। त्यो जस्तै तल भयो भने के हुन्छ, अब वुड प्लेस गर्दाखेरि डिस्प्लेस त हुन्छ, तर डिस्प्लेस भएको वाटर त्यो पोखिँदैन अनि बिकरमा कलेक्ट हुँदैन। तर पहिले नै के हुन्छ, एकदम अप टु लेभल, स्पाउटको लेभलसम्म पानी भर्ने। अब वुड हामीले जब राख्छौँ, त्यो पिस अफ वुड राख्छौँ नि, नाउ इट डिस्प्लेसेस वाटर, राइट। अब यो डिस्प्लेस वाटर यहाँनिर आउनु कलेक्ट हुनुभन्दा पहिला नै, सो वी हेभ द आइडिया अफ वेट अफ एम्प्टी बिकर, राइट। एम्प्टी बिकर कति थियो भने हामीले पहिले नै मेजर गरिसकेका हुन्छौँ, रेकर्ड गरिसकेका हुन्छौँ। नाउ वेन द वाटर स्टार्ट्स कमिङ फ्रम द स्पाउट अफ युरेका क्यान बाई द डिस्प्लेसमेन्ट अफ वाटर बाई दिस वुड, यो जुन वुड छ, वुडले वाटरलाई डिस्प्लेस गरेपछि जुन पानी पोखेर यहाँ भरिन्छ, त्यसपछि नाउ इट सोज न्यू वेट, and that is the weight of beaker plus displaced water. And finally, the difference of weight of beaker and displaced liquid and weight of empty beaker only, then we get weight of displaced water, and that is also found 40 Newton. यो हुन्छ नि, यो एक्टिभिटी गर्ने नै हो हैन। Practically when you do, we find that equal value, that weight of object in here and the weight of liquid displaced. So whenever the body is floating, यो फ्लोटिङ हुने केसमा चाहिँ यो हुन्छ नै। मानौ यो वुडको 40 न्यूटन वेट रियल वेट एयरमा थियो भने, अब डिस्प्लेस वाटर जुन छ त्यसको वेट पनि कति हुन्छ, 40 न्यूटन। Means W1 is always equal to W2, and it happens so in the conditions of flotation. Flotation हुँदाखेरि हुन्छ। Okay, this way we can verify the law of flotations. There is another method also just to show that law of flotation works. Here, students, for this we have taken Eureka can students, and in this case, again, that already the Eureka can that filled with water is placed on the top and balance. Means now this balance, okay, this top and balance shows the weight of water. So inside the, that kept inside the Eureka can. Right? Now let's take a body, so which floats on water. Okay, पानीमा float हुने एउटा body लियौँ. For example, woodकै टुक्रा लियौँ है. Let's take a piece of wood and immerse in it. So when we immerse, when we keep the piece of wood inside the water, obviously it displaces water, and the displaced water is overflown and then get collected in beaker. हामीले साइडमा राखेको एम्प्टी बिकर जुन छ यहाँनिर राखेको त्यो बिकरमा फिल हुन्छ, राइट? अब कुरा के हुन्छ नि स्टुडेन्ट्स, okay, though yes the piece of wood displaces water, that means some of the water is lost, yeah, from Eureka can. पहिला युरेका क्यानमा जति वाटर थियो नि, यो पिस अफ वुड राखेपछि त त्यो अब वाटर यहाँबाट बाहिर जान्छ भनेको लस हुन्छ नि. दो द वाटर इज लस्ट फ्रम युरेका क्यान, बट द टप एन्ड ब्यालेन्स सो द सेम वेट. सुरुमा ओके, यहाँनिर जुन सुरुमा छ नानी हो, ओके, यो टाइममा वाटर मात्र हुँदाखेरि यो टप एन्ड ब्यालेन्सले जति वेट देखाउँथ्यो नि, देखाउँछ नि, ओके, अनि आफ्टर प्लेसिङ द पिस अफ वुड अल्सो इट सोज द सेम वेट. So the same weight means what, Mr.? That means the weight of displaced water is equal to weight of this body. Means that weight of piece of wood means weight of floating body is equal to weight of displaced water. So by this method also, so we can verify, yeah, law of flotation experimentally. Now let me go to another slide, students. This is the example of law of flotation. This is a log of wood, so which is found floating, okay, on water. Because it experiences upthrust which is equal to its weight. It happens due to the density of water more than the density of wood. And density of water at instant temperature is 1000 kg per meter cube in SI system and 1 gram per centimeter cube in CGS system. And the density of wood varies from that 600 to 800. That means if you take average density of wood as 800 kg per meter cube, okay, that means 0.8 gram per centimeter cube, it is obviously less than the density of water. So why the wood, okay, log of wood, so always floats on water, because the wood having less density can displace the liquid or water equal to its weight. Yeah, this is the example showing the flotation. Now let's read, okay, the conditions that determine the sinking or floating of a body. The main factor that determines the sinking or floating of a body is density, either density of liquid or density of a body. So if you say density of liquid, so when a density of liquid is more than the density of body immersed in it, that means at the time a body always floats, right? When the density of liquid is less, okay, than the density of body, for example, density of water is 1000 kg per meter cube. The density of iron is 7860 kg per meter cube. Means the density of water is less than the density of iron, right? So in that case, now the iron sinks in water because the density of liquid is less than the density of body. So density of liquid more than density of body, a body floats. Density of liquid less than the density of body, at the time of body sinks. Then there is another case also. So what happens when the density of liquid is equal to the density of body? So in that case also a body floats, yeah, on the liquid. That means there are three conditions, so where we can find whether a body sinks or floats on a liquid. Let's discuss the first condition there, that is a sinking. Okay, a body is sinking. You can see the diagram, that is A, figure A. The body is found settled at the bottom, okay, of the vessels, means it is sinking. So in this case, students, that the weight of a body is greater than the weight of displaced liquid, is greater than the upthrust. So we can show what happens there, okay, especially the consequence of density between Okay, a body sinking and the liquid. So W1 is greater than W2. Here W1 means weight of body, and W2 is that is weight of displaced liquid, isn't it? In that case, students, so if we express the formula as a weight of body is mg, means W1 is equal to m1g, and you can see that W2 is equal to m2g, and gg, they are in the same place, so they are constant. Finally we get the relation between m1 is greater than m2. So density is equal to mass upon volume, right? So mass means what? Density to volume here. So m1 is greater than m2, means it is d1 b1 is greater than into d2 b2. And here, students, in this case, so when a body is sinking in a liquid, that volume of body is always equal to volume of displaced liquid, means b1 is equal to b2. So since b1 is equal to b2, then we find that density 1 is equal to density 2, means greater than density 2, means density of a body is greater than density of liquid. So when a density of a body is greater than density of liquid, a body always sinks, okay, in the liquid. Second case is the students. This is the floating. A body floats, and there are two ways how a body floats, and this is the case where a body floats just below the surface. So you cannot see any portion of the body out of the water, okay, out of the liquid. So or let's say in the air, it is floating, okay, this body is floating, but this is just below the surface. And it happens when the density of both objects, means the density of liquid is equal to density of that body. It happens, okay, that a body floats in such a way, okay, when the density of a body is equal to density of liquid, according to the principle given by that flotation's law. Okay, we have what? Weight of body is equal to weight of displaced liquid, right? That means a weight of body is equal to upthrust. And if you assume that W1 as weight of body, W2 is equal to, that is weight of displaced liquid, they are equal, and we have M1 is equal to M2, right? And in this case also, you see the whole portion of body is immersed, okay, inside the liquid, means B1 is equal to B2, right? That means finally we have D1 is equal to D2, because already we have D1 B1 is equal to D2 B2. बुझ्यो है? अब यसरी पनि body float हुन्छ just below the surface of water. That means we do not see any part, okay, out of the liquid. So in this case, that the densities, okay, of both substances, means liquid and body are equal. Let's see third case. Okay, the third case is the students. Now we find a body floating, okay, on liquid with some of its part outside the liquid. अब यसरी पनि float हुन्छ हेर त. Okay, so it is floating. Okay, it's some part, some portion is in the air, means out of liquid. Okay, some portion is inside the liquid and some portion is outside the liquid. It happens when the density of liquid is more than the density of body. Means when D1 is density of body and D2 is density of liquid. So when D1 is less than density, D2 means density of liquid. It happens like that. Okay. Let's just find the relations. So how we get D1 is less than D2? Just obeying the law of flotation strength. Let's consider that B1 is total volume of body and B2 is volume of displaced liquid. And you know, volume of displaced liquid is always equal to volume of immersed part of the body. Okay, and for D1 is density of body, okay, D2 is density of the liquid. And we have the law of flotations. According to it, we have floating body weight. Okay, floating body's weight is equal to weight of displaced liquid. Means assuming that W1 equal to W2, that W1 is weight of body, okay, and W2 is weight of displaced liquid. And in place of W1, we have put formula as M1G equal M2G. So finally we get B1 equal B1 D1 equal B2 D2. So in place of M1 we have B1 D1, in place of M2 we have B2 D2. But here is strange. So B1 is greater than B2. B1 is total volume, right? But B2 is the volume of immersed part of the body. That means the total volume is always greater than the immersed part of the volume. Means the volume of displaced liquid. Since V1 is greater than V2, and for this relations, there must be D1 less than D2. Means D2 must be greater than D1. बुझ्यो है? बडीको टोटल भोल्युम डिस्प्लेस लिक्विडको भोल्युम भन्दा है ठुलो छ भने त अनि त्यो दुईटाको वेट बराबर हुनको लागि के हुनु पर्यो त हैन अनि अर्कोको डेन्सिटी बढी हुनु पर्यो नि त जस्तै V1 ठुलो छ भने अब D1 ठुलो हुनु भएन D1 के हुनु पर्यो सानो हुनु पर्यो अनि पो V1 र D1 को प्रोडक्ट अनि V2 र D2 को प्रोडक्टसँग बराबर हुन्छ so right so in this case right V1 is greater than V2 that total volume is greater than okay volume of displaced liquid means that the okay D2 is greater than D1 means that the density of liquid is greater than density of body. So when we find a body floating so with some of its part outside the water obviously okay we have to know that the density of water is greater than the density of body. बुझिन्छ ल ओके आजलाई यति नै